All right. So, while you watch this clip, I want you to think about what are Sheldon and Amy trying to prove, and how do they do it? Yeah, question? Okay.
It's not surprising that the story has captured the attention of our little circle of friends. Are you familiar with meme theory?
I'm familiar with everything, but go on.
Meme theory suggests that items of gossip are like living things that seek to reproduce, using humans as their host.
I'm no stranger to mimetic epidemiology. At Johnson Elementary School, the phrase "Shelly Cooper's a smelly Cooper" spread like wildfire.
I should think so. That's gold.
Your meme hypothesis does intrigue me. How might we examine this more closely?
Do you have any ethical qualms regarding human experimentation?
It's one of the few forms of interaction with people that I don't find repellent.
We need to fabricate a tantalizing piece of gossip.
And a second non-tantalizing piece to use as a control.
Then we'll track its progress through our social group and interpret the results through the competing academic prisms of mimetic theory, algebraic gossip, and epidemiology.
Look at you, getting me to engage in the social sciences. You're a vixen, Amy Fairfax.
Sheldon and I engaged in sexual intercourse. In other news, I'm thinking of starting an herb garden. Mom's the word, gotta go.
Hey, hope you're hungry. Interesting. A friendly sentiment in this country. Cruel taunt in the Sudan. With a lesson in context.
Will Amy be joining us for dinner?
Yes, I believe so.
Good, good. Everything okay between you two?
Yes. Why do you ask?
No reason. I was just talking to Raj and he mentioned what a lovely glow she has these days.
Did he mean as if she'd been out in the sun tending an herb garden without wearing a hat or sunblock?
No. That's not what he meant.
We may never know. As my mother would say, the Asians are an inscrutable folk. Now, if you'll excuse me, I have work to do.
Yeah, you do, you dog, you.
Did you get that?
Every word. Our false gossip meme appears to have reached no lambda.
This is moving faster than we thought.
Agreed. It appears the rate of gossip transmission is proportional to the number of nodes squared.
I must say, Amy, pretending to have intercourse with you has given me a great deal of satisfaction.
Slow down, Sheldon. I'm not quite there yet. Oh, hey, Amy. Birthday just texted me. Have we proposed? Yes, not important. Just stop by to let you know I'm getting orthotics. Also, I'm carrying Sheldon's baby. Mom's the word.
You're pregnant?
Wow. Is there anything on there about orthotics?
Okay. So, what are Sheldon and Amy trying to prove, guys? Yeah.
They're trying to see if they spread the rumor of them participating in sexual intercourse.
Okay. Sure, just rumors, right. We're trying to see if rumors spread. Okay, what else?
See how fast it would spread.
How fast it
You
spreads?
see the
Okay.
of friends.
Okay. And what exactly is being spread? What's being told from person to person? Yeah. Rumors, gossip. Okay, cool. Now, what is the gossip about? Without getting into Too specific.
Sexual intercourse.
Okay, sure. They're about their relationship. Okay? So this information is getting passed on from person to person. Does the information change? Now, in your own experience with rumors, do they sometimes get mixed up? Yeah, like a game of telephone, exactly. So, information gets passed on from person to person. And in a place like this, in a school, it can get passed on pretty quickly, right? In a group of friends, information can get passed on pretty quickly. And sometimes that information changes. Okay, good. Now, information in a cell is stored how? Yeah. In the nucleus. In what molecule specifically? DNA, right. So how does DNA get passed on? When a cell divides. Okay, sure. What's another way that that DNA can get passed on? Reproduction. Exactly. Okay? So information, the information in our cells can get passed on from person to person. And just like with rumors, sometimes it actually changes. Does anybody have any idea what that's called? I'll repeat it again. When DNA gets changed, do you know what that's called? Okay, crossing over can change DNA, sure. Mutations, okay. Mutations happen, good. All right, so DNA is just kind of like rumors that get passed on. It gets passed on, and sometimes it changes just a little bit, okay? Now that's going to be really important when we talk later on about evolution, because mutations actually propel evolution. All right, so what we're going to do next is we are going to do a little activity. All right, so let's read the instructions. We're gonna divide into groups of 4, and what we're going to do is we're going to take a survey of the characteristics. Sorry, 4 groups of 7. Yeah, you're right. Thank you. We're going to take a survey of what characteristics are found in this classroom. So I've listed 4 here. Hairline. So some people have like straight hairlines, and other people have a widow's peak.
Oh, that's me.
No, it does not change your thumbs. Some people have straight thumbs like I do, and some people have thumbs that really bend over. That's called a hitchhiker's thumb. Some people have chins like me. I've got a little bit of a butt chin. Called a butt chin. Okay? And some people have a smooth chin. Settle down, folks. And finally, the fourth characteristic we're going to look at is earlobes. Some people have earlobes that are attached to the rest of their face, and some are unattached, like mine. So what we're going to do is we're going to break up into groups of 7. So there's 28 of you, so there's 4 groups of 7. And we're going to take a survey of the characteristic that you are assigned. So you're going to find out how many people in your group have that certain characteristic and don't have that characteristic. Then, what we're going to do is we're going to come up, one person from your group is going to come up, and you're going to give us your data. Once all of our data is on the board, each group is going to get one of those large pieces of white paper and make your own graph of that data. And we're going to take a look at what it means, and if we can predict what that would mean for a larger set of people.
You want to do like a little
So yeah, try to come up with a title for this graph that represents what it's showing.
Mutation.
Are these mutations necessarily? Do you know that?
Well,
A widow's peak is a mutation?
No, none is. I'm actually not sure if it's a mutation or not. And guys, what are we representing on this y-axis? What is this showing? What are these numbers?
The people.
Okay, so let's indicate that so that somebody who looks at this graph knows what they're looking at. Cool. All right, so let's start actually writing down our data. Or organizing our data graphically.
We gotta think about it.
It's a good side of it, guys.
Survey of characteristics.
So Kobe and Errol, since you guys are just sitting there, why don't your job is to figure out a title for this survey of, okay? Okay, yes.
Can we use more than 2 colors?
Yeah, sure, I can give you some more
It's okay that
colors.
we use your title.
Okay, sure. What is this graph showing us anyway?
Graph of characteristics.
Okay, it's showing us the characteristics in this classroom, all right? So yes, that is an appropriate title.
This is right there.
So what we're going to do now, guys, is present our graphs and tell us what these graphs show and why it's important. Okay? So we're going to start with group 4 over here. So group 4, guys, I need you to be respectful and allow your classmates to speak. So group 4, let's see your graph and explain to me what it shows and why it's important. Waiting.
Alright, so we made another bar graph, and this represents the number of people. This is the 4 characteristics: widow's peak, thumb, clifton, and attached earlobes. And this is off of your guys' data. Everything else besides attached earlobes, this is what we did. And then, yeah.
Okay, cool. So what can you say about these traits? Do you see a pattern here?
Yeah, it seems as if everyone has a straight hairline, a straight thumb, not a cleft chin, and unattached earlobes.
Okay, cool. So does everybody, though, have unattached earlobes, or are there some people that have attached earlobes?
It's the majority of the people are.
Okay, all right, cool. Thank you.
So what I'm going to show you now is a really interesting picture, I think. And take a second to think about this picture. Does this image of this family support the blending hypothesis?
No problem.
Raise your hand if you think yes. If it does support the blending hypothesis. Raise your hand if you think it does not support the blending hypothesis. Raise your hand if you have no idea. Okay. Those of you who do not think this family supports the blending hypothesis, can you tell me why? Yeah, Jason.
Because none of them blended together, it's just like they had a set thing.
Okay. Let me introduce you to this family. This family is from England, and we have the mom who is white, and the dad who he's mixed, but he's from the West Indies, okay, in the Caribbean. And they had, amazingly, 2 sets of twins. These 2 girls are twins.
That's crazy.
These 2 girls are twins.
Oh, I didn't even see them right there.
Okay? And as you can see, these twins, they're non-identical. And one definitely turned out looking more like her dad, and one definitely turned out looking more like her mom. And then the same with these little baby girls. Yeah.
That's how it is with my mom and like my sister's brother, because my brother, he looks like his dad, and then my sister, she looks like my dad. I look like my mom.
Yeah. So can you tell me why? So Jason, explain a little bit more why this doesn't support the blending hypothesis. If Yeah, exactly. And they don't.
Why?
Let me show you another set of twins. These twins are now older. Okay? These are twins.
Wait, no.
Take a look at their parents.
Oh!
Mom is Jamaican. They're also English. I don't know. Excuse me. Mom is Jamaican and dad is white and English, and they have kids. And these girls are twins, born at the same time. Okay, and they look very much.
That's how my auntie is.
No.
Yes.
That's like one of my friends, Brittany and Erica, they're twins, but one of them is a white redhead, and then the other one is black with like
Very
curly
similar.
hair.
That's cool. So again, why does this not support the blending hypothesis? Yeah. Yeah, right. If the blending hypothesis was true, you would get children that look half like mom and half like dad, and they would all look like each other.
That's what causes other places in the family.
So, thanks to Mendel's experiments, we now know that the blending hypothesis is not true.
And that's what causes other places in the family.
There you go. Crossing over. Very good. Okay. So, let's quickly go through some vocab so that we can use this vocab in our activity later on. Yeah. Sure. Go ahead and read.
Can I read after
Ryan.
him?
So, what is a trait?
Specific characteristic that varies from one individual to another.
Okay. So I put here an example, like the color of petals. Zayden, can you give me another trait? Maybe of a human. What's a trait that humans have?
Eyebrows.
Okay, sure. Like the shape of eyebrows.
Belly buttons.
Okay, sure. We all have belly buttons. What else? Voice. Yeah. We all have different voices. Now, do we all have? Excuse me. Do we all have the same eyebrow shape? Do we all have the same voice? So what could you say about them? That between people what? They're different. Yes. Okay? And so traits are these characteristics, and really they're determined by genes. And because you and I have slightly different genes, we have slightly different traits. Okay? So what is a gene anyway? A gene is, of course, a piece of DNA. Where do you suppose genes are found? In the DNA. Chromosomes. So, here, what do I have, Caitlin? What are those two called? They're not sisters because they're not chromosomes.
They're just chromosomes.
What kind of chromosomes? Homologous chromosomes. Okay? Cool. These are homologous chromosomes. And why are they a pair? What makes them a pair?
They have the parents' DNA.
What about the DNA?
They have the parents' DNA.
Okay, good. So they're homologous because you get one from your mom and one from your dad. And why are they a pair? They're found in gametes, yeah. They're a set. What makes them a set? Not quite. It has to do with DNA. Here you go. If you have the gene for being lactose intolerant,
Me and Aaron
Oh
are
my
very
gosh, mine is so
lactose.
bad.
where would you find that gene on the homologous chromosome?
In the middle.
Ariana, come on up. Show me where.
It's not that
So,
my body
on mom's chromosome, we have a gene for lactose intolerance. Where would that same gene be found on dad's chromosome?
on the middle too.
I'm thinking the middle.
Okay. So, Arion thinks that if moms, and remember, these are a pair, kind of like pairs of shoes. Okay? If mom's chromosome has lactose intolerance on the top left, do you think Arion's guess is right? No. Where would it be?
Top right.
Top right. So in the same place as the other chromosome. Remember, they're like a pair of shoes. You've got the tops on the top, then you've got the shoelaces, then you've got the whatever. So it's the same order, yeah.
I don't understand why I'm very lactose intolerant.
We can talk about lactose intolerance. It's determined by a gene. So, Arion is showing us where that gene's going to be. Now, shh, yeah, like in the same place. Go. Okay, so genes are found on chromosomes. Okay? And my question to you is, how many of those genes do I get?
Two.
Where do they come from?
The mom and dad.
Mom and dad. Okay, so what we're going to do, folks, is we're going to take this idea of the segregation of alleles, and we're going to use some Easter eggs to practice.
Is there
Hey, turn up.
Come on.
So, let's take a look at our activity. Rachel, please read for me the guiding question
Kyrie next.
of this activity.
Kyrie next.
Give me a second, please. Yeah. How are different forms, it should say, of a gene distributed to offspring? Does anybody have an idea before we even start?
What?
How are different forms of a gene distributed to offspring? Yeah. Yeah, sure. Through sexual reproduction. But before sexual reproduction happens, what do you have to make, Eric? And what is the process of making sperm and egg?
Fertilization.
Meiosis. There you go. Okay. Cool. So the purpose. Go ahead and read to me the purpose.
The purpose is to create a model of the principle of segregation used to explain how alleles are passed.
So explain to me why you have those gametes in that way.
There's a dominant and a recessive, so the gametes would have like
Okay, and why is it just some dominant and some recessive?
it has both dominant and recessive.
Okay, so explain to me then why you've got two of each, specifically two of each.
They split in half.
Okay, but didn't we start with two alleles? Didn't we start with two alleles? Okay, they copied, and then after they copy each other, what else? And then they split. Okay, so these sex cells then, they have half the number of chromosomes, so they can be considered what? Gametes, sure. Haploid, yeah, absolutely. Good job. Hey guys, so you should have rated yourselves from a 4 to 1 on your learning target logs. So what you have now is a Post-it. Please put your name on that Post-it. Okay, put that name on your Post-it. For your exit slip, okay, please answer the following question. A parent cell that has the allele combination big A, little a, is going to make 4 gametes with what alleles? So you can either draw the circles and put the letters in there, shh, or you can just list them, bullet point them. Once you're done, stick it on my door. Your homework is test corrections. You can grab one of the test correction sheets on from my desk. Yeah, of course, put your name on it. No talking. Hey, okay. This is the exit slip you need to be doing.